Assignment 6.5 on logistic equations. Here we go. In number 1, it tells you there's a k value. First of all, they tell you it's logistic. There's an m value of 200, and that p at 0 is equal to 10. This is what we have to know. So we practice till we know it. So I don't really want to. Let's go one step at a time. Write a differential equation for that. That's the first part. That's dp by dt. We take the values k and m, and p stays in there. There it is. For part B, sketch the population of the slope field. So in your book, you can do this. Start at 10, and then kind of follow what's happening, and you can see here, and then you can see at 200 it's going to be it. That's part B. Part C, find a formula for P. Show all steps using partial fractions. So we're going to do this from scratch again, like we did for the lesson. So we're going to solve this by separating the variables. So I'm going to divide by P, 200 subtract P. I'm going to multiply by dt. So now they're separated. I'm going to show, to integrate this, I need partial fractions. So I'm going to show that work. A over P plus B over 200 minus P. And that's equal to 1 over P 200 minus P. To get common denominators, multiply by 200, take away P, and multiply by P. That's just the numerators. Use the zeros. So if I plug in 200, I get 200B is equal to 1, so that's 1 over 200. If I use 0, I get 200A, that's a 200. So A is 1 over 200. All right. So I'm going to come back here. I'm going to use those values, 1 over 200. So I'll come back here. So I have 1 over 200. That's 1 over P. I have, 1 over 200. That's 1 over 200 minus P for the B. The derivative of this is negative, so I need a negative in front. That's why I was trying to leave a space there. And then when I integrate the left, it's just 0.00025 t plus c. These are going to be logarithms. So it's 1 over 200 ln p minus 1 over 200 ln 200 minus p. We're just going to work until we can get p by itself. So we've integrated, now we need to solve for p. I'm going to multiply by 200. 200 times this, that's going to change that to a 5. I think it's 0.5, 0.05. So if I multiply it by 200, that changes it to 0.05. I'm going to use property of logarithms. I'm going to divide. I'm going to write this exponentially. Oh, and I might as well do this right away. So to remove the bars, plus or minus, we're going to replace the constant. Really, when I multiply by 200, this should be C2. And then when I replace it again, it'll be C3. Now we're going to do the reciprocal to both sides. A better way to write this is a constant e to the negative 0.05t. Then I got 200 over p. I'll do it over here. I have 200 over p minus p over p. And I have a constant, really it's the fourth constant that I've now used, e to the negative 0.05t. This is negative 1, so I'm going to add that to the other side. And then I'm going to do the reciprocal again. Usually the 1 comes first, constant. And then the last step is to multiply by 200. And you did it. Then it said, then we plug in the value that we have. So at this step, we're going to plug in 10 and 0. So when I plug in 0 for t, that just leaves me with that. So this obviously needs to be 19 for that to work. Because 1 plus 19 is 20, and 200 divided by 20 is 10. So now we have an equation. 200, 1 plus 19 e to the negative 0.05t. Woo! Easy peasy. We got it. Then it asks, when is the population growing the fastest? So the population is growing the fastest when the derivative is equal to 0. So I'm going to use my calculator. Take the derivative equal to 0. Make sure I'm doing it right. This is that derivative of the derivative. So it's growing the fastest. Growing is the derivative. When is the derivative of the derivative equal to 0 in terms of when it's growing the fastest? And for these, certainly seems so take out a calculator. Let's do this. Solve an equation. So we're going to use the derivative of the derivative. So we're going to take the derivative, menu calculus, and derivative. It's with respect to p. So what we wrote down to begin with, which is 0.00025 p times 200 minus p. From the very beginning. Make that equal to 0. There you go. So it certainly looks like, at least for these models, right, that whatever the maximum value is, halfway there is when it's going the fastest. So I want to keep an eye on that if that's true all the way through. That halfway there, it's going the fastest. So if this is it, then halfway there, when p equals 100, it's going the fastest. So then I have to solve this equation. So take out your calculator and solve that equation. When is that happening? Halfway there. So I'm going to keep an eye on that. So menu, algebra solve. So 100 equals, control divide for that, 200 over 1 plus 19e to the exponent negative 0.05 t, comma t. and that was at 58.8889. And I don't even have a unit. All right, that was number one. Number two. If dp by dt equals 0.04p minus 0.0004p squared, find k and m. Well, I'm going to have to factor out a p. In fact, I'll factor out 0.04p. I'd even do better than that, 0.0004p. And then what I'm left with when I factor that out, 0.0004p, and do that, is that 100? So I factor it out, and then I can see K is 0.0004, and the maximum capacity is 100. Just factoring it out and putting it in the form that we had at the beginning. Number three. Match each of these differential equations with one of the slope fields. So we have this one, and this one. So this one I'm drawn to because I can see that 100 is the carrying capacity. So when I look here, I see this is 100 where the horizontal is. So I'm definitely feeling good that 4 matches with A. It's logistic. I get the same sense here. And if you have negative here, in fact, I probably have to multiply it by 150 to get a sense of it. So if I multiply this by 150, I don't even care about the number in front right now. If I multiply it by 150, or factor it out, I would be left with 150 minus y. So if you factor out a 150, this is what you'd be left with. And so that's the carrying capacity, 150. That's right there, B. So sometimes you got to rearrange it in a way that makes sense. This is not a logistic model. So just 0.065y, this is like ky, this is like PERT. Oops. So this is just a growth function, just rising up, E, whatever, right? So it matches with C. Number 6. So given this logistic equation, find the carrying capacity. That's 2,000. Let me write it down. So here's the logistic. So the carrying capacity is the numerator. What's the value for K? So K times M is negative 0.6. M we said is 2,000. So divide by 2,000. Negative 0.6 divided by 2,000, and that is 0.003. Oh, that's true. It needs the negative with it. So negative, that makes this positive. And that gives you 0.0003 if you use your calculator. Part C, find the initial population. So for that, I plug in 0. and I get the answer 2,000 divided by 20, which is 100. Part D, find the time at which the population reaches 500. So take the equation, use your calculator, make it equal to 500. I think you can now do it without me. So in your calculator, solve, type this in, comma T at the end, and if you did it correctly, it's 3.076. E, give the logistic differential equation. That's this. So it starts with KP. It's this right here. Where is it that we started with? Right here. So it starts with KP and then M minus P. This is all you got to remember. KP, M minus P. So K is 0.0003 P, and then M minus P, which is 2,000 minus P. There's your differential logistic equation. All right, number 7. We'll do just a few more and for this video. So given the differential equation, 2y, 1 minus y over 50, find the value of k. So I'm going to factor out a 50 in front. So you got 50. 50 minus y. I don't like how I did that. So factor out a 1. Let's try that again. So if I do, let me see how I can see this. So I want that just to be y. So if I factor out a 1 over 150, then this must be, for it to multiply, this must be 50, because 1 over 50 times 50 is 1. And then 2 divided by 50. I don't know what 2 over 50 is. 0.04? No. 0.03? What's 2 divided by 50? 1 over 25. .04. So we started with, oh shoot. This is number 8. Ha! I'll do number 7 right after it. That's why I was confused. I was looking on the answer key for number 7. Anyways, same thing for number 8. Okay, so this is 0.04y. 50 minus y. Now it's in the form where I can actually do something with it. Alright? So now when it says, find the value of k, k is 0.04. M, you can see, is 50. And then give the logistic equation of 0 and 10. All right, lost space here. So we know K is 0.04. The carrying capacity is 50. And so it says the initial population for it is 10. So we have 50. We have 1 plus E negative. Now if I multiply these together, 50 times 0.04. 50 times 0.04, that's 2. And then T, there it is. And then plug in 0 and make it equal to 10. So e to the 0 is 1, so 1 plus 1, oops, there's a C in here. and then think, what would that be? So 55, right? So C must equal 4 for that to fit. So the equation then would be this. 50 over 1 plus 4 e to the negative 2t. All right, back. And then this is our last one, number 7. Then I'll do one start with number 9. Let's see if I write down number 7 to begin with. That would be helpful, right? So number 7, 0.03 p, 100 minus p. All right, this is a lot easier. What's the k value? It's in the right form, right? So it makes it easier. So the k value is 0.03. B says, what's the m value? The carrying capacity, that's 100. And then what would the equation be? So the carrying capacity, 1 plus some constant times e to the negative. Now I need to multiply those together. So that's going to move the decimal 2 to the right. So that's negative 3t. And then it says, find the value of p when it is the greatest, when the derivative is the greatest. And so my understanding is halfway there. So 7, a half of the carrying capacity. So there you go. Anyway, that's the equation. Didn't even ask for the equation, right? So it just says find the value of p. So it's half of the carrying capacity when it's the greatest. So when the population is 50, it's growing the fastest. And it's the greatest. The derivative is the greatest. So we're now going forward going to understand that if I know that the greatest capacity halfway there is when it's growing the fastest. That's a logistic growth model. All right, Mr. G Math over and out. I'm proud of you for doing your work. We're going to continue this on another video. Till next time.